Hello, good evening, everyone.
Good evening, sir.
Yeah, so is my sound clear and my video is clear?
Yes, sir.
Yes, sir.
Okay, thank you. So I request you all, please, unmute, mute yourself, and when you want to say something, then just only unmute.
Okay, sir.
Okay, yeah, thank you. So first of all, I welcome you all for this first live session for NPTEL course, uh, Aspen Plus. So I think you all aware about NPTEL courses.
Yes, sir.
Yeah. So they are like professors, so they give lectures online, okay, and they also provide their course content and all. And every week we have a live session. So the purpose of this live session are that we will discuss the previous week's course content, like we will summarize the. Please mute yourself. Actually, I think someone are unmuted, so it's creating some disturbance. So whenever you want to say something, then only unmute. Okay. So the purpose of these sessions are to summarize the previous week course content so that it will be like a summary session for you. And in this session, we will also discuss some basic practice questions. So that will be very helpful for you do the assignment for your current course. Because in every week, I think you have some assignments, so you have to do the questions. So in these sessions, we will go through multiple problems that will be like you can say similar to your assignment. So you will get an idea and an overview what type of question will be in the assignment and what type of like strategy you should use and like how to approach the question and all. And we will also discuss uh, some problems that maybe you are facing in your previous assignments, but in this session we will not discuss your current assignment questions. Okay, so like this is the session for week 1, so please don't ask any question regarding your week 1 assignment. Okay, so in next session you may ask about the previous week assignments question. So that is the point. So anything else, any doubt, please ask if you want to ask anything.
No, sir.
Yeah, Hemal, you were saying something.
No, sir.
I think someone is saying something, but the sound is not like very low actually.
Hello.
Yeah. Please. Actually, your sound is not clear to me. Please type your question in your in the chat box. Yeah, because your voice is very low actually. Try to speak louder or check your mic.
Sir, chatbot is off.
Okay, you are not able to. Okay, let me check the settings. Okay, it is not enabled. Please try now. Is the meeting chat option is there on the left side? I think you can.
Question and answer is there. I think it will be
Near the Q&A there is chat option. Okay, so maybe we can start. So I think Anchal want to say something. Yeah, Anchal, you can say something. You raised your
Hello,
hand.
sir.
Yeah, Anchal.
Yes, sir.
Hi.
Am I audible to you?
Yeah, you are audible. Yeah, please.
Yes, sir. So recorded session will be provided to us.
Yeah. So let me clear. So these sessions are being recorded. Okay. So NPTEL team will share a Google Drive link with you and a link for the channel. So that will be like my channel. So in that you will find the recording for this session and in Google Drive link you will find the PPT that will be like used in the session actually. So you will get each material, okay, the PPT and the recorded video. So no issue in that. But I request you all, like in this session, the best outcome of this session will be if you will participate actually, okay. So like this will be like interactive session. So when we solve the question, so I will try to ask like please try to participate in solving the questions in practice question. So and try like this is first session. I think there are so many attendees today. So please like be like this in each session. So, okay, so let's begin with the session. So, okay, let me introduce myself. So, just start with the session, okay? So, I think my screen is visible to you.
Yes.
Yes, sir.
Okay.
Yes, sir.
Okay, thank you. And is my pointer is also visible?
It is
Yes,
very
sir.
small.
Sir, small है बहुत ज़्यादा.
Can you see now?
Yes, sir.
Is it okay?
Yes, sir.
Okay. So again, I welcome you all. Good evening. My name is Amit Kumar Sharma, and I am the course TA for the course Aspen Plus Simulation Software, a basic course for the beginners. So the course instructor for this course is Professor Prabir Kumar Shah from IIT Guwahati, and I am the course TA. So every week on Sunday from 7 to 9, we will be meeting here. Okay. So please try to attend each session, because in each session you will get to know so many things. So just because we have already spent 10 minutes, I think. So let's begin with the session. So anyone having any doubt regarding the session and all, so we can first discuss that and then just quickly start the session. Anyone is having any doubt?
Sir, I
Okay.
have a one doubt. How to
Yeah,
choose
please.
method used to determine different properties like electrolyte in Aspen?
Okay, no, actually, yeah, no, not that like doubt. Actually, I'm asking about any like for this session and all, because we will going to discuss. So maybe you will get to know things that we are going to discuss in your, maybe your question will be clear in that, or maybe yeah, you can share. I think there is a form. So if your question is like in detail, so you can also post the question in the course form. So there also
sir.
the NPTEL team will put the answer, because this in this session the main purpose is to show you the how to solve the question. Okay, so we will stick to that, and if your doubt is in like detail, then maybe you can post in the forum also.
How will we get the license from Aspen?
Sir,
Is it like we get a mail from NPTEL, or else I've not got
I
any, I've
think
not received any.
I think they have already shared the email regarding the software and all. I think please check your mailbox if you have
Yeah,
not
we
received.
got.
Sir, we
Sorry,
got.
sir,
Yeah.
actually I
We
don't
have to
have
download.
doubt, but I am facing problem in installation.
Okay. Installation. Okay. So maybe if you are facing installation, I think they have provided a complete sheet how to use the license server and all. So actually, sometime if you are having any antivirus, so that antivirus can cause some like the server issue. So that block the server. Yeah. So please try to uninstall antivirus or like look into your firewall. Or otherwise,
Sir,
if you are not able to, yeah,
problem
let
is
me
that
complete.
after completing all the install, like whatever they have written in their PDF, guide PDF,
Okay.
then
Okay.
I did the same. But after installing all the things, I didn't get the same. Like after 26 page, there is a you have to type Aspen 1 SLM LI on
Okay.
your
Okay.
Windows search bar,
Okay.
and then
I
you will
got your
get the
point.
license manager. But I didn't find this in my laptop.
Okay, I got your point. Maybe you can take some screenshot and share with NPTEL team actually, yeah.
So
So
I have
anyone who,
shared.
so they will reply, you have to wait it, yeah. Please put a
Okay.
yeah, please put a reminder. So
Okay, thank
okay,
you, sir.
okay, welcome. So let's start with the session. So if you are facing any issue with the license and all, I request you all go through the PDF, and if your issue
Yes,
is
sir.
not resolved from that PDF, then you should email the NPTEL team. Okay, because you need the software for this course, so you should have the software in your system. So please try to email them, and like if the issue is with antivirus and all, try to resolve that. And as soon as you have software, then it will be good. Yeah. So, okay, let's.
No, sir.
So this is the last
Same
question. Yeah,
problem.
anyone? The last question. Then we will start the session. Last question, please. Okay, I think somebody is saying that he has not received the email. Then I am saying the same answer. Please email the NPTEL team. You have the NPTEL team's email address. Please put your email there, because I think they have shared the email regarding the same, because many of you have already received. If you have not received, please put an email. Okay. Okay, if anybody have any further questions, so please put your question on the chat box, or we can discuss at the end of this class, because we have already spent 12 minutes. Okay, then just because we have so many questions, so let's just begin the session, and at the end of the session we can further discuss your doubts.
Sir, will you be sharing these slides?
The slides and the recording will be shared with you. Okay, the slides that I'm using here, and the session is being recorded, so it will be shared to you.
Okay, thank you.
Okay. So first, like we will cover the previous week course content. Okay, so basically, what is the Aspen Plus? Okay, like why do we need a software like this to solve the problems? Like, and what is the purpose of this software actually? That's the like a basic question. So basically, Aspen Plus is a simulation software. Okay, in this we can simulate, or we can make the please mute everyone. Please mute yourself whenever you want to say. If you have any doubt, then only unmute yourself. Otherwise, please mute. It's creating a disturbance. Okay. So here you can see the process layout. So this is a like a layout for a, you can say, a refinery or a distillation unit. So in that we have like multiple components, because if in any system there are like balance of plant equipments, BOPs we can say in short. So in any process plant there are many equipments. Here you can say like we have heat exchangers, we have distillation units, we have pumps. Okay, so we have many equipments. So if we are going to install a system, so then if we know all the flow rates, all the pressure parameters, all the heat duty, heat requirements, then it will be very easy for design engineers to do the setup and do the perfect installation. And in future also, if you want to optimize the system, then like suppose if you have already installed the system, then it will be very difficult for you to do the changes in that. So that's why first we want to make a design in a software, and we will simulate the system with the parameters in software itself. So we can optimize all the parameters, we can optimize the efficiency. Okay, we can optimize what is our like the main output and all. So we can do in the software. Then with that optimization, we will know what is the design requirement for each component, what will be the requirement of pressure, what is the requirement of pipe, and all, like there are many parameters. So we will have the detail of all those parameters. Then we can do the designing part. So basically it will save the like so much money of any company, because if you install a system and your system is not optimized, then you have lost so much money in that. But if you have a software that can do all the thermodynamic calculation, all the equilibrium calculation, all the optimization and all, so then you can save a lot of money. You can have an efficient system. So like this is a plant. So in this we have, like this is a basic schematic. So each system have some equations. So there's a mathematical formulation. Each system, like basically we use mass and energy balance, and all the energy equations, mass equation. So and there are various differential equations. Like each component have their own equation. So this software make all the equation and all, and make their in the background they are doing all these calculations. So basically this is the window of Aspen software. Here you can see this system is represented like this. So here we are having some blocks. So we can put these blocks, we will connect the stream to these blocks, and we will give the input that we require to give. Then in the background, it will use these kind of equation. So you can refer to the class material for the more detail about these equation and all. So it will solve the question and it will achieve the convergence. And at the point where all the systems, all the equation for each subcomponent satisfied, then only it will give you the result. So this is the basic functioning of the Aspen. So there are three approaches: a sequential modular approach, then equation oriented approach, and the combinational approach. So in sequential modular approach, so unit operation blocks or modules or blocks are there. We will connect them and we will solve some certain equation for a steady state operation. So that is Aspen Plus. So this course is for Aspen Plus. In this course, we will use already available blocks that are available in the Aspen. We will not create any new block. We have already blocks in Aspen Plus. They have already predefined all equations. We have to just connect them. We have to provide the inputs to them. We can change the inputs. We can change the configuration. We can change the connection and all, and we will have our results. We are not going to make any new model. In another approach, in equation oriented approach, there are some complex system like a fuel cell. So if you want to design a system, you have all the thermodynamic equation for that. You know all the equation, electrochemical reactions, and all the equation and all the kinetics parameter, all the parameters that required for the to reach the equilibrium and all. So you can use those all equation. Then you can customize your model and you can use this approach. And another is a combinational approach in which you will use your custom modeler and also use your Aspen Plus. It is called Aspen Dynamics. So it's a dynamic simulation. So in the class, we have used this kind of example. So in this, an equimolar stream of N-pentane and hexane at 140 Fahrenheit and 75 psi. So we have given two components, N-pentane and hexane. We have given the temperature and the pressure. Then it's fed to a vessel where it is placed to 15 psi with vapor liquid products in equilibrium at 130 Fahrenheit. Use Rolle's law for the simulation of the system. So we have given this kind of problem in the class, and professor has shown both the theoretical solution and a solution from the Aspen. So you can refer to the class notes for further details. So basically, whenever you have a problem, so try to this is a basic thing. If you want to solve in that Aspen, so just make a diagram like this. So you have a vessel in which this is your feed. You know the quantity, 50% mole and pentane and hexane. You know the pressure, temperature. There will be two outputs, liquid and vapor. Okay. So now you know input, you know the pressure and the temperature that the reactions are happening. So you can use this data. Then you can go to the Aspen. You can use there are model palettes. You can use that and you can feed these data and you will get the results. So another is that when you are using Aspen, so there are different types of file and the extension. So you should know about these. So that template file, user model, input, backup, document, and compound. So the extensions are .apt, apm, inp, .bkp, apw, and apwz. So these two are quite important. Each file have their own function. Template, if you working in a company and if you want to fix your template, then you can save in that file. These are all ASCII files and these are two are binary file. So you can save the templates of your units, your property method. Okay. In user model file, you can customize user models for non-standard unit operations. So if you have non-standard units, you can use that. And basically .bkp is contain input information and results, and it's .apw, it's input information, results, and convergence information. And apwg is a zip file, so it contains both bkp and apw. So you can save as per your requirement. But the benefit of this backup file is that I think it's ASCII. You can open it in the command prompt if you are if your storage is broke and you have that copy, and you can easily open this, so you can know your data. Then there are type of setup runs. So first is the property estimation, then asset data analysis, property analysis, data regression, and flow sheet. So property estimation is a standalone. Okay. So first of all, when we are trying to when we have a problem, then first we have to define the components that we are going to use. So basically, we should know the property of those components. Like if you want to use air, then you should know all the property of air. What is the density? Okay, like these properties. So you should know all the properties. So in the Aspen, whenever you select a component, then there are multiple database. So the software will find all the properties for that particular component, and it will store in the system. It will retrieve those property to solve the equation that are used for your complete flow sheet. So the important type is this is standalone. It's not dependent on anything. So first of all, you need the property estimation. It's a standalone process. Then the asset data, it's also standalone. It is used for like petroleum asset and blends, because in petroleum, like we use some different kinds of blend. They have each different properties. So we use these kind of things. Then the property analysis to generate property tables, pressure, temperature, envelope, residue curve, maps, and other property reports. Then data regression, it's also standalone. So if you don't have the exact property, then you use this. You have some kind of experimental result and some results, so you can use this regression tools to fit the physical properties of that particular those components. And the flow sheet, so it's dependent. So the flow sheet is the sheet in which it's called like as in the initial slide we have seen the Aspen window in which all the subcomponents of a system is connected. So that's called a flow sheet. So it's dependent. For standard process, simultaneous simulation including sensitivity studies and optimization. So basically in which it is dependent on like, because in this we are connecting various subcomponents to make a complete system. So each component is dependent on this previous and the next component to that particular subcomponent. Somebody want to say something?
Hello, sir. Good evening, sir.
Yeah, hello. Yeah, please say. Please, what is your doubt?
Sir, I installed Aspen Plus, sir, but during setup, sir, required login and ID or license number.
Yeah, actually, I think you have joined late. I have already explained that regarding the doubts of the installation and all. Please take screenshots and all and put an email to the NPTEL team, because they are the concerned person for the licensing and all. Okay.
Good.
Yeah. Okay. Thank you. So what is the procedure for the modeling and simulation? So in this we have first setup. In that we will do that. We will give a title to our model. Then we will we can type a description and purpose of the job. Then units. So we have to select which type of unit we want to use, because different types of units are there. We can do that. Then the component. So chemical components to work with, like you are working with water, air, and pentane and hexane. Then you have to select those components. Then the properties. So you need to define the property. So you need to call the properties. So all the physical and thermodynamic properties method and model. Then the blocks, and choosing unit operation block for the simulation environment, because in Aspen Plus we have already defined blocks in the model palette. So you can use those blocks, you can connect those blocks as you want, and then you can give your inputs and give your input parameters, and you can solve the system. Then the stream, connecting feed and energy streams to the blocks. So like you in these streams only you have to provide input, and in through these streams only you will receive the output. Then run, and simulation and analysis of the result. So you will get the results, then you can analyze your results. So this is a basic operation like setup, units, then components, properties, blocks, streams, and run. So for setting the environment, like properties environment, we need to define components, physical properties, thermodynamic properties, equilibrium models, gas models, simulation. We have flow sheets, blocks into operation, and streams, and mass and energy. So these are some data banks. Like when we are selecting components, and these are data banks like pure 37, aqueous, solids, inorganic, APUS, okay, NIST, So these are the components, and these are the content, and these are the like use. Like primary component data bank in Aspen Plus, this is, and the aqueous is simulation containing electrolytes. Solids is the simulation containing electrolytes and solids. So like different use are there. So you need to select. So we have the data bank for different type of data bank we have for different use. Okay, and there is in Aspen also there is a option for help. So if you don't know anything about that, and if you want to know more about that thing, so you can use the help section. So in help section, if you type your query, so that will give you result in like what kind of the literature they are using for that term, and what is the meaning of that term, what is the process behind that. Because Aspen already having some like predefined equations model that have already published, that have proven, okay, so that is using those all those things. So they have all the repository for that, so you can type your query and you can get the result there, like how they are doing it. So the help section is very good. If you want to know more detail about any of these things, I prefer to use help. So there are different types of property method, and also I think there is in Aspen there is method assistance is also there. So you can use that tool also, in which you can define like what kind of problem you have. Based on that, it will suggest you like this property method you have to use. So in this we have ideal model, equation of state model, like cubic equation of state. It will cover these things. Then Peng-Robinson is quite famous. So then this different models are there, Lee Kessler, etc. Then activity coefficient models are there, NRTL. Okay, so different models are there. If you want to go through these in further, you can use the help section, and the reference is also given. So measure non-ideal case. So equation of states and the activity coefficient. So good for vapor phase modeling and liquids of low polarity. Okay, and preferable for the liquid phases. Equation of states like try to avoid non-ideal liquids, less requirement of binary parameters, extrapolation of data possible, and good for critical region of pressure and temperature. Like the activity coefficient also like only valid for the given temperature range, critical region to be avoided, like that. So this is the difference in these two. So we have also recommended few methods. So for the TEG dehydration, you can use Peng-Robinson glycol package, sour water, sour PR, sour SRK. For cryogenic air separation, Peng-Robinson, PRSV, TST, atmospheric tower, PR options, TST, GS, vacuum towers, ethylene. For chemical systems, activity models like NRTL, QUSE, TRSV, okay, for compression and light gases, MBWR. So different types of package are there, different types of property methods are there, okay. As per your system, you need to select a property method because the property method is the best thing, okay. Because if you are working with some different types of, like, there will be components, there will be different types of chemical interaction will be there, different types of equilibrium, reaction kinetics, and all things will be there. So your property method should be in sync with your question actually. So you need to first define clearly like which property method you have to use. If you are not sure, use the property assistance that is provided in the Aspen. So now, like these, in this slide, I want to show you the different types of, you can see the color coding actually. So first you will see like this, like we have to give some inputs, okay? And if your inputs are incomplete, then you will see this kind of sign. It's a circle with half red and half white. So if this kind of sign is there, it means that your inputs are not complete, okay? So if you see the blue tick, the blue circle with white tick, then your inputs are complete. And if you see the circle, red color and white cross, then you have results, but with error. Okay. So these are the some symbols you can use. And on the top also you can see the run, the next. So whenever you give a particular input, then always use next. It is advisable because it will automatically take you the next step where you need to provide some data. So next is the best thing. After like all the input is complete, then it will automatically show you that your inputs are complete. Now you can run the simulation. Then you can use the run system. So this is the window. After you open the Aspen, then you will see like this. So in this, I want to show you the, like you can see there is a property section. We are on the properties, then simulation, then safety, energy. So first the property, okay. So in this you will define the component. In this you will define the component. If you type any component, it will search automatically. If it is like the component that came here, it's not as per your requirement, you can click on the find button. Then you can find the required component there. Okay. And there like so this section is, there is a question mark is there, so it's for help actually. So you can click on this section, so it will take you to the help segment in which you can type your query and you will get to know more detail about your query. So it's very useful.
So where is the find button? That where is the find button and what for you can use this?
The find is here. So this is the find button, okay. So like suppose you want like a typical compound N-pentane and like a different version of N-pentane. So maybe there are multiple pentanes. So if you see that the compound that came here is not as like you required, then you can click on find. Then you will have a different list there. I will show you in our like upcoming slides. It will be there. Don't worry. So basically in find button, we have more option to search because the Aspen database is very big actually. So you in find option, like it's like a filter. So you have more option there. You can define the boiling point. You can define some parameters to search the exact component. So, okay. So that was.
Amit. Hello.
Hello. Yes. Yes.
Amit. Will you load the system and show us the system how it works? Like it will be more practical rather than showing in slides.
Yeah. Yeah. I will show that also. But first we will go through the question, and with the during the questions, I will go through the actual Aspen. Yeah. it was like quick recap because these all things were already taught in the class. So it was quick recap. So now we will do the question. In this, I will try to go through the Aspen software also. Yeah. So, okay, the first question is, which among the following equipments is not there in the example process plant shown in the lecture 1? So in lecture,
Turbine.
Turbine.
yeah,
Turbine.
Turbine, sir.
yeah, nice. So in the first lecture, we had a sample problem. So in this, there was distillation column, heater, and reactor. There was no turbine. So the correct answer is B. Which of the following equimolar fluid mixture has been used in the flash vaporizer
And
example in
butane
lecture
and
1?
heptane.
Pentane and hexane.
N-pentane and N-hexane.
C option.
And pentane and hexane.
Okay,
The option. Right.
maybe we can use the Q&A session. I think you can type your, maybe you can type your answer. Okay, I think, yeah. Is everybody able to use the Q&A session?
Option C is the right answer. Option C.
Okay. Just a minute. I'm just exploring the Q&A option. Okay. Please, anyone, can you type the answer in the Q&A? Are you able to type the answer?
Yes, sir.
Just please type. I want to see, am I able to see that or not? Okay, I am getting the answer. Okay. Okay. So the correct answer is D, N-pentane and N-hexane. Now for a simulation to run, the degrees of freedom should be equal to
Option C.
option C, 1. Okay.
C.
Anyone?
0.
8.
Yes, sir.
Zero.
B.
0.
0.
Number of unknowns should be 0.
Yeah. So basically, it's like we are doing the flow sheet calculation. So it's a just you have all the balance of mass and energy and all. So the degree of freedom should be 0 because it's a flow sheet program. Okay. So degrees of freedom should be 0. Which of the following is not a correct approach for Aspen simulation? So sequential modular
Option D,
approach,
model set approach.
equation oriented approach, then the combinational approach, model set approach.
Option D. Model set
Option
approach.
D. So like in sequential modular approach that we are going to use the Aspen plus. So in this, like we have already predefined models in the Aspen. Like we have some model palettes there. So we are going to use those model palettes to make our system, and we will give input to those models and we will solve it in a sequential model approach. Okay. The equation oriented approach, it's like you will have your equations. You don't have the predefined model in Aspen, then you have to build your own model. You will use the equations for that, and that will be like a dynamic case. So it's equation oriented approach like custom modeler. In the combinational, it's a combination of both. So this model set approach is not in the Aspen simulation. So correct answer is D. Property analysis is a standalone type of run, while flow sheet is a dependent type of run. True or false?
True.
True, sir.
True.
If anybody want to explain what is the property analysis?
Property analysis is just like electrolyte properties and the other parameters we are defined.
Okay.
It is the estimation of properties of a chemical compound and its sensitivity with temperature, pressure.
Okay. Anybody else?
Sir, property analysis is used for the generation of tables of the report of the which property are we going to use there.
Okay.
The property analysis is like what is the boiling point, what is the flash point, such type
So
of
why?
analysis of a, while flow sheet is a dependent, it's like a full simulations.
Okay. So what is the like main need of this property? Suppose if I don't do the property analysis, will be I like am I able to go to the flow sheet or not?
No, we won't
No,
be
sir.
able to
Actually,
go.
not, because we can't predict the reaction. If we
Yes,
don't
yes.
have the property of the chemicals used in the particular reaction, then we can't predict the property of product or kind of product and byproduct, etc.
So what is then the flow sheet mean? What will be in the flow sheet?
A mathematical model of like some complex reaction.
Okay. So is it like only a complete like flow sheet mean you mean to say only the one model, complete model, or the combination of all the components and all things?
Flow sheet contains all the components and properties of all that components.
So basically the flow sheet, the property analysis, basically suppose if you want to work with certain components, okay, certain chemical components, certain components, so they will have some kind of properties, physical properties, thermodynamic properties, okay, chemical properties, different type of properties they have. So we have database. So first we will define those components, then the system will find the properties for those component. Okay, now system will have all the properties, like as you all said, like what is the boiling point, okay, and the critical pressure, temperature, and like viscosity. Okay, if there is any like reaction, then the kinetic parameters for those things and all. And in flow sheet, suppose we want to do some like if we want to use a pump and we want to use a like a condenser, or like we want to use a flash separator, like we want to use something, we want to do some reaction as we also used in our example. So we are using those models, and in that model we are giving inputs, we are receiving outputs and all. So it's like a complete connection of multiple equations, okay, like we are solving it. So we need all the properties to solve this to solve those equation, mass and energy balance, do the mass and energy balance. We need all the properties for that. We need convergence so that each equation is satisfies satisfy, okay. So in this the flow sheet is dependent, because it will like if you are having a model, then it have like number of equations, so each equation is dependent on this, like the previous, like the convergence mean it will maybe go through some iterative processes, like maybe the 100 iteration will be there, or like maybe 500 or 1000. So in each they are dependent on the previous one. So it's dependent, it will depend on the property, it will depend on their equations and the all the equilibrium and all. So the flow sheet will be dependent type of run, and the property analysis is standalone. Okay, the correct answer is true. The correct order in which the following reactors models are placed in Aspen Plus version 12.1 model palette. Have you all been through the model palette, Aspen Plus? Okay, maybe some of you are not able to install software, so let me show you the software now.
No, sir.
Let me share my screen. Are you able to see the screen?
Yes, sir.
Okay.
Yes, sir.
So
Yes,
this
sir.
is the screen. So I am using version 12. Okay. So when you open it, so this kind of screen will be there. So in which we have like left side new option. If you want to create a new file, if you have already an existing file, so you can click on open and you can open your file. Then the save as all option, you know. So also we have some predefined templates here. We can use these templates. So we have also the points for units also. Okay. Then let's just use the new simulation. So just opening. Are you able to see the screen?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Yeah, it's taking time. Just please wait. It's taking too much time. I don't know why. Okay, just give me a minute.
There's some error appearing in the left bottom corner as it seems.
Oh yeah, it's not about that actually. It's opening. I think some issues with the network. Okay, just give me a moment. Let me check. Okay, are you able to see my screen?
Yes, sir.
Yes, sir.
Actually,
Yes, sir.
software is having some issue now. It's stuck.
Sir, simply click on the simulation. We can get all the equipments there.
Just a moment, please. So when you will open the software, then you have some options. Let me show you those options. So first you need to define the components and all. Then only you can go to the next part. Just open, just wait. Just 1 minute. Okay, so let's start with this actually first. So they are in the sequence like the R yield, then equilibrium, then the Gibbs reactor, then the CSTR. So these are sequence in version 12.1. So maybe whenever you install the software, you can check it, and I will also show you this in the upcoming few minutes. So the correct answer is B. So next question is the icon. There is an icon. Okay. So in the same version, what does it represent? So this icon represent the save layout. If you want to save your layout, then it will do that. So basically the point of this type of question is that because you will also have an exam after your the course, then you should go through all the like icon and all the options of software so that you will be familiar with all these, because maybe these type of question can be in your exam also. So the purpose of to show this type of question is that because is it possible to come this question in your exam. So please go through the things, the options very carefully in the software.
Yes, sir.
So my software is still taking time actually, yeah. So which of the following was not mentioned in what's new in Aspen version 9? I think you will not get to know about this answer because now you are on version 12. So actually, whenever a new version,
Physical property enhancement.
sorry,
C, option C.
option C. Okay. No, actually, it can be maybe different for for each version, because maybe in each version, whenever a new version come, then there will be some modification or some improvement, some new addition in that version. So there is section like what's new. So please mute yourself. Somebody is unmuted. Please mute yourself. Yeah, thank you. So whenever a new version come, like currently we are having version 12, maybe next year version 13 will come, or this year at the end of this year. So whenever that come, then you will have an option what's new. So in that section you can see like what are the improvements in this version and what are the major changes or some what is the addition, improvement and all. So for version 9 it was like simulation environment enhancement. It was not mentioned in that because the environment, the simulation environment will, it's like a major change, so normally it will not be there. So some engineering enhancement will be there. Physical property, they have added some new database because you know, all over the world there are so many researchers are working towards the different kind of properties, different kind of new elements and all, so they will add those in the database. And also the workflow and usability enhancement, because like each year we are using the software, then we will give some feedback to them. They also having some their internal process and all, so they will improve the workflow and the usability of the system. They will do some engineering enhancement, like maybe they will improve their like calculation part, their equation handling part, the methods how they are solving it and all, so they do some major enhancement. Okay, so these kind of things you can see in what's new section. Then which of the following is not a valid type extension in Aspen version 12.1? So we have seen different kinds of file in Aspen. So there are four options: .apm, apn, apt, apw. So which type of
APN.
file?
APN.
Okay. Okay. Yeah. So the correct answer
So
is B, APN. Yeah, please.
what is this sign, that arrow and LE?
It's
Like,
like I also don't know about what is the meaning of
like
this.
it is
It's
not
like
valid or what?
it's
File
like
file
File
those.
type.
extension.
It's file. Yeah, it's meant to say what valid file type. So they represent like this. Yeah, I don't know, because actually we have already questions set by the NPTEL team. Okay, so I don't know. I think it's a file type. Yeah. So basically these are
Okay,
the
sir.
file extension. .apt is for template, apm for user model, then .inp for input, .bkp backup, apw document, and apwz compound. So we don't have .apn. So which of the following is not a valid tab in component specification in Aspen plus 12.1? So it's polymer. Let me check, is my software is working now? It's still not working. What happened? Just wait a minute. I'm trying to open my software. Actually, I think it's having some like issue with the team, or I don't know what's the issue.
Since the IP address for everyone is same, people might have loaded, more number of people might have loaded it and
No, actually, I'm not in India currently, so I'm not using the Aspen that is provided by the IIT Guwahati team. So currently, I'm as a visiting researcher at TU Delft, Netherlands. So I'm using that Aspen. So I think it's issue with actually my laptop is not that fast, and maybe the Teams is running, and due to and the recording is also on, and due to all the things, I think it's slow a little bit. Yeah. I just restarted it. Let me just. Okay, still waiting for it. Okay, let's see. So I have some screenshots for you, no issue. So when we select a component, so this is the window you will see. So in component section, you can see like we have petroleum, non-conventional, enterprise database, and so basically these three databases are there. Okay, here you see the component ID. So you will type. Let me show you the. Is it pointer? Yeah. Okay. So here you will type. Here you will type the component name, so it will automatically appear. If it's like a complex component, you can click on the find button and you can search that particular component. And we have like petroleum, non-conventional, and enterprise databases. So the correct answer is option A. So we don't have the polymer. Okay, so the polymer is not a valid tab in the component specifications. So which of the following is not a valid search criteria to find compounds from database in Aspen plus V12? So the viscosity, we have the name, alive, the molecular weight, and the boiling point. We have these options. We can use these things to search a particular component, but we don't have the option for to search with the viscosity. So this is the window. When you click on this find button, this window will open. Okay, so you can see here. So you can the search criteria. So you can like search either you know the name. There is some alias. So the system is used that number also, and there is also a CSRN number. So if you know that number from your like previous experience with the Aspen or some database, you can directly use that number. You can use like begin with, contain, equal, and all. You can also select the different classes of like compound class. You can define the molecular weight. Like you don't know the exact weight, but you know the range. Like it will be near 20 to 30. So you can type 20 to 30. So it will show you all the component. Those have the molecular weight in that range. You can also define the boiling point. You can select the unit here. Okay. So here you will see the compound names and all things. Okay. So you can select that compound and it will appear in your property specification, and the Aspen will recognize that component and will calculate all the properties for that component, and that component will be ready for your simulation. So I think one of you was having doubt regarding find. Now I think it's clear. You can see these are the options in the find. Okay, so you can use these options to find the particular compounds that you want to use. Any doubt regarding this?
No, sir.
No, sir.
Okay.
No, sir.
So my software is still really, I think it's having issue with the team actually. Yeah. not working. Let me try once again. This last try. So there is a Lee-Kessler property method. So Lee-Kessler property method is a cubic equation of state model based method, like true or false. So it's false. Actually, when you will be like quite an expert in the system, then you will get to know like which property method is like which type of that method is. So this cubic equations of states. So this screenshot is from the Aspen help section. So you can type the cubic equations there. Like then you will have the different types of cubic equation of state available in the Aspen system. So these are some example of cubic equation of state, the property method which are using those. So these are the methods which are having the cubic equations of state. So this Lee-Kessler don't have the cubic equations of state. It have a different method. If you want to know more about this, you can use the Aspen help section. Just type the Lee-Kessler property method, and you will have all detail like what is the meaning of this, the purpose of this, what are the equations used in this method, and all. You will get to know about that.
The Lee-Kessler is used for non-ideal, na? Non-ideal fluid reaction, like Lee-Kessler or Walls, or something Walral equation, something like which
Yeah,
you
actually, I
have
am
shown
also
to us.
because I only use
Mm.
Peng Robinson for my work. Actually, I don't know more about this, so you have to check it. Yeah,
Okay, okay,
yeah,
okay.
you have to check it. Yeah,
That is also we can find in Aspen.
yeah. Aspen, Aspen plus help is very good. Actually, I want to show you, but really my system, why I don't know why it's not working. Actually, yeah, I don't know why.
Okay.
Yeah. So if you have installed your software, then if you go on the right top corner, then there is a sign of help. Just click on that. Then you will be able, like a whole window is there. There is a left side index and all options are there. On the right again top option, you can write your query and will give you the results.
Sir, whenever you install
Yeah.
Aspen Plus 1264 version, then asking sir password and keyword.
Yeah, actually, I already told you because I don't have the all the knowledge about how to install the given Aspen that they gave you. If you have any query regarding that, because I think they have provided a complete PDF. If you have followed all the
Yeah.
steps from that PDF, it should work. If it's not working, maybe it's due to your antivirus. If you don't have any antivirus and all things, then you should email the NPTEL team. They will look into it. Yeah,
So
because
that
mostly,
query,
please.
actually, you have to put your laptop name like Dell or something you have written in your, like, first check your profile, and then you have to put your password. What is your laptop password? Then it will work. Try once. Like
Yeah,
laptop
so
name, whatever the username of your laptop and the password. Try
so
once,
you can
it will work.
so you can
There is
try
one
this
prompt.
method.
It
Yeah.
says use system. I use that. I use system as a user, so that worked. Earlier, I was also facing the same problem.
Please repeat
Yes,
once
yes.
again.
Put system
Yeah.
in space of username and click on next. It will
Yes,
work.
that's it. That's it. That's it.
Yeah, maybe you can also mention this thing in the chat box. So maybe if anybody else want to know, so he can just follow the chat box. Actually, yeah.
I'll
Please,
do that. I'll do that.
yeah, please write
Yes,
it in the
right in chat
chat
box.
box. Yeah. Okay, so now again, what approach does Aspen Plus have to simulation?
Sequential modular.
B option. Sequential
So
modular.
sequential modular, because we know that for equation oriented, we have to make our own model, so that will come under the custom modular. Aspen Plus use the sequential modular. Okay, so we have all like predefined modules, we have predefined blocks, we have a sequence, we use that sequential modular approach to solve our system problem. A dynamic simulation with non-standard equipment model can be done using space software package. So see, these kind of questions can be in your exam, okay, in your assignments, like fill in the blanks. So you don't have any options, now you have to give the answer. Anybody?
Aspen Dynamics.
Aspen dynamic. Yeah.
Okay, Aspen Dynamics. Just wait for 1 more minute if anybody else
Dynamics.
want to answer. Okay. So the software package is the Aspen custom modeler or Aspen custom modeler equation oriented approach. So the dynamic simulation come under this. So Aspen custom modeler software package. So this is the name of software package. So the answer will be accepted in like these two form. Write any of I think these things, it will be correct. Okay, so basically equation oriented approach or Aspen custom modeler. In Aspen Plus, the required input complete is indicated with a red tick in white circle, black tick in red circle, white tick in blue circle, green tick in blue circle.
Green tick in
White
blue
White
circle.
tick in blue.
White
Option
tick in
C.
blue
Sorry,
circle.
white tick in blue
C.
circle.
White tick in blue circle.
White tick in blue circle.
Option C.
Option C. Okay, we have so many options C. Let's see the answer. Yeah, so white tick in blue circle. So you can see here. So whenever your input is finished, you have given all the inputs, and you see there will be a blue circle and there is a white tick. Okay, so this is the representation that your inputs are complete. So now the Aspen Plus is available
Windows.
for which operating
Windows.
system?
Windows.
Windows.
Windows. Okay, so yeah, Aspen is only for Windows. So we don't have for Linux, Mac OS, and Android. It's only for the Windows. So which of these file types or extension is not affiliated to Aspen Plus?
DAT.
Dot DAT.
So I think this kind of question we have already covered. So we don't have .dat. So we have .apt, apm, inp, bkp, apw, apwz. So we don't have .dat files. Okay. So the purpose of to show these kind of questions. So the point is that be specific about the things. Okay. Go through all the like file types, the different types of option, the model palettes, the sequence of model palettes. Okay. The methods that are used in the Aspen. So question come from like any of these. So try to like cover all the things. Just don't do only the modeling directly. Just you have just like as you have learned all like basic modeling and you have just started solving those like directly those questions. So don't go in that approach. First understand the software, understand the package, what is the which package you are using, which kind of like different methods are there, what kind of file types and extension are there. So go through all these things, then only proceed further.
So
Again,
maybe
a good
this
question.
type of question, like objective question, will come in the exam.
Yeah, I think, yeah, and you will have fill in the blanks, you will have like multiple correct answer and like that. So you will get a, I think before exam you will get a also a PDF in that all the instruction and types of maybe you will contain, and in your assignment you will see multiple questions. So similar to that, I think it will be in your exams or assignments. Yeah, the exact, I don't know the exact what will be the pattern, but you will get info about that. But these types of question will be in your assignment also, because your assignment also have some weightage in your exam, in your like passing marks. So in assignment you will see these kind of questions. So the symbol white cross in the red circle means incomplete input, complete input, results available but with error, and change in input parameters. So the answer is result available but with error. So you will see this kind of symbol will be there. So you see the blocks. So blocks means that we have already some blocks there. Okay. So if you're using a block, then it will be like named B1, or you can change the name, you can rename it. But if you are having some results, but with error, like you have given some like different values. So system is running, system is trying to convert. Somebody is unmuted, please mute yourself. Yeah, thank you. So like suppose if your inputs are not correct, okay, you have some, you gave some like vague inputs, but you have a complete connected system, and like then the software will try to converse the problem, okay, try to use the properties that you have already specified, try to use the inputs that you gave, and it will try to come to a solution, but then it will not converge, okay, or it will have a different kind of error. Maybe the equilibrium is not achieved, maybe the mass balance is not completed, maybe the energy balance is not satisfied. So these kind of like error will be there, like basically the system model is not satisfied, okay, with your inputs. So basically you have like wrong results. So but it will show some results, okay, but there will be some error, or it can be different kind of error will be there. So it depends actually. So what kind of error, but the representation of this is this white cross with red circle. So if this is there, then it means that your system, your model is not running perfectly, okay, it have some issue, it have some error that you have to address. Then you have to go to the result section, okay, or stream results. Then it will show you, like in summary also, it will show you some kind of info that yeah, this error is there and you have to rectify that. So troubleshooting is also a very important part. Sometimes it will directly indicate the exact error, but sometimes when you do the modeling, sometimes actually the error is due to some other component, but it appearing at some other component. Okay. So the troubleshooting part is also quite difficult in complex modeling. If you are doing only like using a one block, but you are having multiple, a complete power plant modeling, a complete system modeling in which you have like number of subcomponents, like tens of heat exchanger, different of like condenser, and you are having different like reactors and all things. Okay. So then maybe you have error. It will also mention that this system is not running, but maybe that error is due to some other input that you gave somewhere else, actually in some other component. So that part is also very important. It's quite initially it will be very difficult for you, but after only practice you will get to know like yeah, this is the issue. So troubleshooting is also a very important part of modeling. So practice it. Okay, my system is also not, my Aspen is not working. I'm sorry for that. Okay, so yeah, the red circle with white cross. Then the property analysis is a standalone setup run that may yield property estimation and asset data analysis calculation. true or false?
True.
Okay.
True.
Anyone else? Please also explain your reasoning. Why it's true and what is the meaning of this standalone like property analysis standalone setup? I think we have already covered, but in short, just in 1 or 2 sentences, you can explain.
Property analysis, it is a standalone setup because it's independent. Because if we are not analyze what property methods we are going to use, or we are not defined the calculations that are required, then we cannot proceed to the further part, that is the flow sheet part. So it is important for us to first complete the property analysis.
Yeah, nice. So yes, it's true. So basically, it's a standalone. It will not depend on your flow sheet. Okay, like you have specified some components. That's okay. System will run, do the property analysis for those components that you specified. It's totally a standalone setup. The properties environment consists of flowsheet, logs, and streams. True or false?
False.
False.
It should be false.
Okay, why is that?
Flow sheet blocks and streams are available in simulation environment. It's not in the
Yeah.
properties.
So it's in the simulation environment where you make your flow sheet for the calculation. So it is in the simulation environment, not in the properties environment. Okay. So in properties environment, you just specify the components and all things, and you will just get the properties for those. It's false. So this is the like environment you can see on the left side, like properties and simulation. You can see these. Then properties. So you will specify the component here. Okay, like component ID, you will type it, and it will take automatically the component, and it will show you the type, the component name, and the alias and the CS number. Okay. So you can do that. Then just you will run it. It will get all the properties. Then you will go to the simulation environment. So you can see there are 2 sections here. The maximum number of characters that can be assigned for making a component ID is
8. Within 8.
8.
Okay. So like in component ID, we can type a name there. So but it has some limitation. Maybe your component having like 12 characters, but you cannot enter 12 characters. Okay.
6.
You can enter only up to
6.
8. Up to 8 characters. You can enter up to 8 characters only. So if you are not able to get the exact component that you want to add in your property database with 8 characters, then you can use the find option. In find, you can type your like 8 characters, then you will get a list. Okay. Then you can select your desired component. But it can only maximum number of characters that can assign for a mega component ID is 8. The components compounds can be searched. Yeah.
Sir, why
yeah,
that
please.
accepted answer is 7.9 or 8.1? Why not 8.0 only?
Yeah. Actually, they have some type of like some kind of range. Actually, yeah. It will only 8. Actually, 8 will be the answer.
Okay, sir.
Yeah.
Thank you.
Sir,
Yeah.
I don't get this question. Like, I have doubt in this question. Like, maximum number of characters, component
Yeah.
ID. I didn't get it. Can you please
Actually, you
explain?
see, you see this in component ID. You can type a name here. Actually, yeah. So like,
Okay.
yeah. So like, suppose if you want to add voter, so you can type WATER. So when you press the enter, then it will automatically take the voter. It will automatically show you the H2O and all the like the number, that CS number in the database. It will automatically show you. But suppose your name is having more than 8 characters, like WATER. Voter is only like if with like in the limit. So So you can type it here. But suppose
Okay.
your component is having like 12 characters, so you cannot type that 12 character here. Then you need to, maybe the system is having that component, but it has some other component ID for that. You don't,
Okay,
so
sir.
you have to do that, or you can also give your own ID. You can also specify your own ID. Suppose the name is quite long, actually name is maybe like some complex components have like 14 characters, 15 characters. So this system will automatically give some them ID, and you can also define your own ID. So the limit is 8 characters. So you can define only 8 characters, because these IDs will be like in the backstage, it's doing some calculation. So in those calculation, it has some limitation that it can only accept up to 8 characters. If it is more than that, then that will create a problem for the system. So it will not run. That is the like component ID actually. Yeah.
So when I give them ID, like own ID, then I have to specify their types and component and
No,
all
it
their
will
properties.
it will automatically specified. You just need to select it.
Okay.
Like suppose you want to add H2O in your system. Okay, so the formula is H2O, but we also call it water. So if you type water, then it will automatically get H2O.
Okay.
Okay, it will automatically it will take the data from the database. Just need to type.
Means something related to this, that
Yeah,
component.
yeah, maybe like because some complex, I'm not from chemical engineering, so some complex chemical compound have some like small change in their name only. Okay, so for those you can also specify your own. You can select the compound from the find section, and you can give them your own ID. Like suppose if you want to tell water like A1, so you can type A1 here, but that will still be a water, because it's on the, you see the CS number. So this CS number is having a number that is in the database actually. So that number is important. So you can see the database. So this ID is only like a representation. It's not that component. That component will be from this CS number. Okay, that is the important. So that is from the
Thank
database.
you, sir.
Yeah. So the compounds can be searched on the basis of boiling point or molecular weight. True or false?
True, sir. True.
True.
True, sir.
True.
Okay.
True.
True, sir.
Okay. Let's see the answer. Yeah, it's true. So this is the find component section. Okay. So you can see it begins with, like, you can type name here. Okay. Let me just check my software. Oh, it's running now. So let me share the screen with you. Give me a moment. Are you able to see the Aspen screen?
Yes, sir.
Yes.
No, sir.
Not
Yes, sir.
Okay. So let me go to the properties. So this is the properties. Yeah. So these
Sir,
are the
I am
like
not able
component
to see.
just wait, maybe it's network issue. Are you able to see now?
No, sir.
Anybody
No, sir.
else?
Sir, I am able to see it. It is
Just
visible.
Sir, I'm not able to see.
just wait, it will be visible to you. Yeah.
Sir, it is not visible.
Wait for a moment. I think your system is having like maybe bandwidth issue, because if some of you are able to see, then I think it's visible to everyone. But maybe just wait for a moment. Is it visible now? Everyone? Is it visible?
No, sir.
No, sir.
No, sir.
Okay.
I can see.
No. If some of
Maybe
you
try
can
changing
see,
your
then
view. Choose the view. व्यू ऑप्शन में जाके चेंज करके देखिए एक बार.
Yeah, please do like this. Yeah.
Maybe that is the best idea.
Is it okay now, everyone?
Yes,
Yes,
sir.
sir.
Now I can see that.
Okay.
Okay. Thank you. Thank you. So see, this is the property. Okay. So here we can see, like, suppose if I want to add a new element here. So let me again type water. Actually, I think it's very slow with the team. Yeah. Oh, crashed.
Yeah. Lagging.
Sorry, guys. Actually, I think it's having some issue with the teams. Maybe next
The
time I will
software is
try to.
lagging.
No, actually, it crashed. It crashed. It crashed. Actually, yeah. Just let me try again.
We can do one thing. I have Aspen open in background, so I can share the screen and you can guide. That will save time.
Yeah, it's really good. So what's your name? Maybe I can give you the sharing rights. Let me know your name actually.
My name is Nutan Paliwal.
Please spell it.
Nutan.
And okay. Let me give you the access. But actually, if you share it, then I think my slide will not be visible. Okay.
Fine, you can just guide if that works.
Oh, no, actually, yeah, my PPT should be there actually always. Okay, next time I will try something different to run the software. Maybe I will use a different system. But once please install the software, then you will get to know these things. Yeah, it's not that tough. So it will be, yeah. So let's just go to the questions. Okay. So this is the, okay, so it's true. So we can find by the molecular weight or boiling point. So you can define, like, your component is having a molecular weight from this range. So you can define this, or boiling point, you can define this, and you can find now. So it will give you some results. It will show you all the components. Then you can select the particular component that is relevant to your system. One of the key calculations performed in process simulation is the phase equilibrium calculation. Is it true or false?
It is true.
True.
True, sir.
Is anybody from chemical engineering?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, please explain the phase equilibrium. What is the meaning of this?
Sir, fugacity of a component should be same in two phases if they are. That component needs to be in phase equilibrium.
Okay, and what is this fugacity?
Tendency of a
Shaping
component to
tendency.
vaporize.
Shaping tendency.
I'll try and
what kind of-
explain it in simpler terms.
Yeah,
For
please.
given pressure and temperature, the components which are present in liquid are in direct proportion with the components that are present in vapor phase. The vapor phase and liquid phase is in equilibrium. So they are referring to that phase equilibrium. The fugacity and other terms are concerning the activities of these things. Activities is nothing but concentration in layman's term, although there is
Yeah.
little bit difference in activity in concentration.
And I think that is
So that's
also
that.
connected to the
Yeah.
partial pressure, yeah, in the composition of gas mix. The activity coefficient is also, yeah, taken with the partial pressures of the gases. Yeah, yeah. Okay.
Absolutely.
Also, we
Absolutely.
can say that
Yes, sir.
the state at which the system in which multiple phases coexist.
Coexist. Yeah. Okay. Okay. So, like, what kind of if you are having different kind of reactions, then what the basic things you will need for these to reach this equilibrium? Like if we are having the chemical reaction regarding deforming, so to use the Gibbs free energy and all terms like in the fuel cell and all. So what kind of like extra things do you need to reach the equilibrium calculation?
Mainly
Like
activities is there. Activity is
only
there. Like
activities,
if you have
activities.
component mixture, yeah.
Okay. Okay.
So in liquid phase, you need activity, absolute activities. Activities, you can say concentrations,
In case
etc.
of chemical reaction equilibrium,
Yeah,
the
there.
Gibbs Fenris change of reaction should be minimum at equilibrium to achieve equilibrium condition. And in case of phases, that fugacity is in each or activity phase equilibrium is when suppose there is in case of distillation column, there is a gas phase or vapor phase or liquid phase. Both are these coexist. So these are at equilibrium means there is the net rate of mass transfer
Oh,
is
nice, nice.
equal.
Okay, nice. So good discussion. So yeah, it's good actually. So that's why this session is important. So if you everybody will participate, so we will get to know many things actually. Yeah, so it's good. So let's move further. So it's true. Yeah. So the key calculation performed in the process simulation is the phase equilibrium calculation. So yeah, the ratio of fugacity coefficient in various phases is called. So
Activity.
we discussed. And now we have a
Activity.
question for that. Yeah, nice, nice. So it's called
Activity.
the activity coefficient. And I think this is the formula that professor explained in the class.
Yes, sir.
Okay. So we are having like activities of liquid, and for the I think pure substance, is it F0?
Yes, sir.
Yes, sir.
Yeah, yeah. So these are the relations. So for more detail, you can refer to the class notes and maybe the Aspen help section. So yes, so these are for today's class. The all problems. I think now let me just one more try to the software. Let's see if it works. And meanwhile, maybe we can do one thing now. So we can start a little introduction. Okay, this is the first session, and we still have around 25 minutes left. So maybe I will announce the name. So maybe you can introduce yourself like in a very small way. Just your name.
Sir, I have a doubt.
Yeah, yeah,
Sir.
please.
Sorry for
Please.
interruption.
No, please, yeah.
Tomorrow's class will also be a introduction class, or else it will be the continuation part.
Yeah, okay.
Tomorrow's
So
session.
actually, in this course, there are two TAs. Okay. So we are having like separate classes. So in that tomorrow's class also, there will be a live session for the week 1. Okay. So that is different TA. He's from a different. I am from basically IIT Delhi. He's from I think a different institution, IIT Bombay or something. Yeah. So he will also explain the week 1 course content. So actually there will be the
Yeah, I
same week
understand
1
that.
course. Yeah, the same type of question will be there. The point is to have 2 sessions is that maybe somebody is available on Sunday and somebody is available on Monday. So you have 2 options. Suppose you missed the session for 2 days, you can attend tomorrow's. You don't need to attend both. And if you have enough time, you can attend both. Okay, so it's on you actually.
Okay, sir.
So there is flexibility. So we have 2 sessions. So in which session you feel good, you can join that, or you can join both.
Okay. Sir, this recorded session will be shared with us.
Yeah, yeah. So this record session will be
Uh,
shared to you, and the PPT is also shared to you. Yeah, it will be shared to you. Yeah.
it will be shared by mail, or it will be shared by in the group.
The NPTEL team will email, I think, a Google Drive or maybe a Google Sheet. In that, you will have the link for the videos, for the recordings, and I think you will have the links for the Google Drive in which you can access the PPT. They will
If
they
in
will
case
share.
people will miss both the session of the particular week, they can access it.
Yeah. You
Okay.
can access
Okay.
it. You can access it. No issue. Yeah, you can access that.
Thank you.
Okay. Let me- So maybe the first is Anchala. Maybe you can introduce. So please tell your name and what you are doing currently, like master's, PhD, or you are in an industry, and like what is the profession, and why did you join this course? What is your motive to learn from this course?
Okay, hello everyone. Good evening, sir.
Yeah.
Myself
Good evening.
Anchal Vishwakarma, and I am from Varanasi, UP, and currently I am pursuing a Bachelor of Technology in Department of Chemical Engineering, and currently I am in third year, and I am like applying for this course just for simulation, just for learning the simulation and all, and I think it will help in my internship and placement also.
Oh, nice. Thank you. Thank you, Anchal. And next is Asif. Asif, are you there? I think he's not there. Then Arjuna.
Hi, sir.
Hi, Arjuna. Yeah.
This is Arjuna from ONGC. Currently, I'm working in ONGC.
Oh,
I
nice.
have a 10 years experience in ONGC.
Okay.
Currently, I like to do some research on these some of the aspects. So, Aspen Plus is the one of the module to use this. I like to use this Aspen Plus for my research.
So you are working for like refining part, like distillation. Which part you are working?
Yeah, no. Exploration, actually. This is a
Okay. So like,
ONGC is the exploration.
so what will be your purpose to use the Aspen? Like, what is your main motive to use Aspen? Like, what kind of modeling do you want to do with this software?
Actually, no, I like to recover the CO2
Okay.
because in industries, every industry, we are getting a carbon dioxide.
Yeah.
So to recover the CO2, just I'm doing some research. But Aspen Plus is one of the module. It will help me. Just I'm thinking that, and also I'm with some of the professors also. They were also telling that this Aspen Plus will help us. So just I'm trying this kind of for
Okay.
research.
Nice. Thank you. I think you
Okay.
are industry person. So yeah, maybe in next session we also like further get to know more about like how we can use the software in industry and what is the approach. Maybe yeah, it's good to know.
Okay, sir. Thank you, sir.
Thank you. Then next is Divya Varthini.
Hi everyone. Hi sir.
Hi. Yeah, actually,
My name.
everybody, you can call me Amit. Yeah, no sir is required. You can call me Amit. Yeah, no issue.
Okay. Myself K. Divya Vathini. I am doing BTech Chemical Engineering in Anna University, Chennai. Is second year. Why I'm choosing the Aspen course is for I'm studying in chemical engineering. So the main software for chemical engineering is Aspen, so that I will be able to do that course. It will be useful, improve my career. So that only I choose this course. That's it. That's it, sir.
Okay. Nice.
Thank you.
Thank you. Next, Gaurav. Gaurav, are you there? Okay. Harshil?
Yes. Good evening, everyone.
Yeah. Harshil or
So
Gaurav?
this
Okay,
is
Harshil.
Harshit.
Yeah.
I'm a process engineer with a reputed specialty chemical company, and I'm having a total 8 years of experience in different fields of such as production planning and now process engineering. So my main motivation is to learn and understand the know-hows of the how the reaction chemistry and equipment designing takes place at the micro level.
Okay. So how are you planning to use this software in your research or your like in your company? What is your plan like? What kind of reactions you are doing? Is it reforming some other chemical reactions like what?
So my plan is to by learning this software first to understand how the current equipment designing is done at our plant, and after that I have the understanding and how then I'll implement the skills to further improve the or optimize the process criteria or the designing.
Yeah, nice, nice. Actually, those who are working in an industry, so it's really a good platform for you because you already have the on-site experience. You already know the data, the real-time data that you are using in your designing in your company. So maybe you can try to simulate that similar design in the Aspen because Aspens give you the flexibility and you have all the data, you have all the inputs, you know all the streams data, you know all the pressure because in like one is from I think the last guy was from ONGC and you are also from a company and I think there are many guys from different companies also. So they have the all data with them. Okay. So they don't do some theoretical calculation. Actually, they can do the real calculation. So they can use their data of the company to simulate their plant in the software. And with that, maybe they can improve their existing plant design. And they will get to learn more actually. Yeah. So it's a really good platform for you to learn these things and to apply it in your company. Thank you. Gaurav, are you there? Okay. Next is Hemal.
Good evening, sir. My name is
Yeah.
Hitesh Parulekar.
Good evening.
And I'm pursuing a course of BTech in chemical engineering, and I'm currently in first year. I have a aim to work as a process engineer in the nominated companies or well-known companies like Honeywell, etc. So I'm currently pursuing this course for developing the skills that are required for a process engineer. The main skill that is required, one of the main skill required is of the Aspen Plus software knowledge, which you have to use. So I'm pursuing this course to develop the skills required.
Nice, nice. Thank you. Jiva. Okay. There is. Yeah, Jiva. Yeah, yeah, please. Your Jiva, your sound is very low. Please check your mic.
I'm Jiva Raghavan from Tamil Nadu. I'm currently doing BTech Chemical Engineering and I'm right now third year. I took for my future career because it will be helpful for me in designing engineer and process engineering field.
Okay. Nice, nice. Thank you. Then Kirtana. Kirtana Manoj. Actually, what's the name? If I pronounce it incorrectly, sorry, please. KM Manda. Okay. Okay, next is Mahesari S. Mahesari.S. Okay, Vaishnav Rajesh. Vaishnav Rajesh. Hello.
Hello, am I audible?
Yeah. You are audible. Yeah, please.
Hello, sir.
Vaishnav, your sound is not clear. Please check your mic. Vaishnav, sorry to interrupt. Your sound is not clear actually. Yeah.
Is it clear right now?
Yeah.
Hello?
Now it's clear. Now it's clear. Now it's
Uh,
clear. Yeah.
sir, I'm actually Vaishnav Morie from Thadamalsani Engineering College, Mumbai University. I'm in fourth year. Currently, I'm studying Aspen Plus for my placements, and I have been placed in Voltas Engineering. So they need this skill. So that's the reason why I'm learning this.
Oh, nice. Good. Nutan
Thank you, sir.
Paliwal.
Yeah, hi Amit. This is Nutan Paliwal. I am working with ONGC, and I'm working with ONGC Hajira plant since last 10 years now. So now it's a time that we need to optimize our parameters even more because the gas and oil industry is becoming more and more competitive now.
Yeah, really. Yeah.
To use to say optimize the processes to reduce our energy footprint. So that's why I took this course. Actually, I did it during my bachelor's, but it's been long time now.
Okay, so what kind
So
of
just
process like you are planning to implement this software? What kind of process you want to use?
see, we have one of our processes gas sweetening, that is amine sweetening.
Okay.
So that has a colossally large energy footprint. And the second is we cool the gas to -5 degrees Celsius so as to recover the heavier hydrocarbons.
Okay.
And then pump it to a countrywide pipeline. So we are optimizing that stream also, that to how cool it should be, or how much energy we should put in chilling the gas, so that the finances would not hamper, as well as we'll get the more and more hydrocarbons. So what much is optimum? Currently, we are working for this.
Oh, really nice. So everyone is really nice that we are having two, I think two are from ONGC and one is two are from different companies. So maybe in future classes, it will be good if you share your experience with the modeling. So I think it will be very encouraging for other participants also. So maybe in upcoming class, I will ask you to share your experience, what is your experience and learning from this modeling. Yeah, it will be good for everyone. Yeah.
Sure. What one more thing I would suggest is somehow if we could create a WhatsApp group for this, so it would be nice actually, because there's always I am of the mind that there should always be industry academia collaboration and interaction should always be there. Like you are in TUDL, so you must be realizing it firsthand.
Yeah. Actually, I was in HPCL for 3 years, so I was also in oil industry. So that's why I am very keen to know about what kind of things and you are doing. And currently, I am also working on hydrogen fuel cell. I am working on SOFC, solid oxide fuel cell. So we are integrating biogas and SOFC. So I am working on basically the reforming part, the internal reforming. So yeah, in upcoming class, I will also share my experience. Yeah. In detail. So it will be
Thank you.
Sir, actually, my question is to Nutan, sir. Sir, as you said, you are from Hazira plant ONGC. Are you from Surat?
No, I have been settled here for quite a long time now, 11 years.
Like
Yeah. Do you
Hazira
need any
plant
help in
Surat
Surat? I
or
can help
somewhere else?
okay.
I'm in
Maybe you
Surat,
can
yes.
discuss. Okay, you can discuss over chat. So let's move further.
Okay.
So next is Pranay.
Hi
Pranay?
everyone. I am Pranay.
Yeah, hi Pranay.
Hello.
Yeah, hi Pranay. Hi.
Hello. Hello everyone. I am Pranay Rukar. I am currently pursuing chemical engineering from Pune University. Uh, I am doing this course because I want to improve my software skills and want to pursue my career in process design.
Nice, nice. Thank you. Rahul? Rahul, are you there? Okay. Rohit?
Hi, Amit. This is Rohit Anumandla. I am from ONGC Petro Additions, a subsidiary of ONGC.
Oh, yeah.
I want to learn this Aspen course for upgrading my skills, and also I want to apply it. Currently, I am working in PP plant, polypropylene plant. I want to apply the techniques which I learned here in my plant and optimize a few streams so that it can benefit our plant operations. I am working from past 12 years here. That's about me.
Yeah, nice, nice. It's really great. Yeah. So you are also planning to implement it in your working
In
domain?
polypropylene plant, in polymers, in polypropylene. Yes.
Okay, okay. Great. Nice.
Hello,
Nice.
sir.
Thank you. So,
Myself.
yeah, please. Rahul?
Yes, sir.
Yeah, Rahul. Yeah.
Good evening. Hello, sir. Myself
Yeah.
Rahul Kumar. I am currently I'm working in Siva Pharma, Dahej, in project and process department.
Which company?
Siva Pharma.
Okay. Yeah.
In process and project department. Aspen Plus सर मैंने क्यों किया अभी मैं क्योंकि मुझे अभी प्रोसेस में जानना था प्योरली इसलिए मैं अभी आस्पेन प्लस का मैं अभी सॉफ्ट में अभी NPTEL से मैं सब्सक्राइब किया हूँ अभी
आपका प्लान मतलब इसको आप कैसे इम्प्लीमेंट कैसे करने वाले हैं अपने कंपनी में, जैसे अगर आप काम कर रहे हैं, जो वर्किंग प्रोफेशनल हैं,
सर
तो
मैं
आपका
अभी
क्या?
सर मैं अभी पहले मैं प्रोडक्शन में था सर, ऑपरेशन में
ओके
दीपक
अभी आप
में
नए
दीपक
हैं।
में था
ओके तो अभी आप
दीपक
लर्निंग
में था फिर
करना चाह
आरती
रहे
में
हैं
था
इसको? ओके
हाँ लर्निंग करना चाहता हूँ सर। अभी मैं अभी प्रोजेक्ट डिपार्टमेंट हूँ तो मुझे प्रोसेस में भी थोड़ा देखना पड़ता है, तो मुझे एस्पेन प्लस का भी कुछ अभी नॉलेज चाहिए मुझे, तो मुझे इस सॉफ्टवेयर जानना था, समझना था, इसलिए मैं अभी इसका NPTEL से लिया।
नाइस, थैंक यू
थैंक यू सर।
सचिन? Sachin? Okay.
Yeah, good evening, sir.
Yeah, good evening, Sachin. Good evening. Yeah.
I'm audible?
Yeah, you are audible. Yeah, please continue.
Sir, myself, Sachin Rajput, from IIT Lucknow. I'm third year student, and sir, only for knowledge. So I attend the Aspen Plus.
So you are from chemical engineering or mechanical engineering? You are like which domain?
Chemical engineering.
Chemical engineering.
Chemical engineering.
Okay,
yes, sir.
Nice. Then Sandeep Kumar. Sandeep Kumar. Okay. Then Surya Prakash. Surya Prakash. Surya Prakash, I think you raised your hand, but I'm not able to hear your voice.
Can you hear me now? Hello?
Yeah, you are audible.
Hi, Amit.
Hi.
Thank you for teaching us.
No, actually, I'm not teaching this. We are having a casual discussion. So I will learn from you, and maybe I will also able to give something back. Yeah.
Okay. I did my chemical engineering some years back. So after that, I gave civil service examinations. So I'm planning to become a process engineer next. So that's why I'm here.
Okay. So currently you are like in a company or like?
No. I'm moving away from civil service preparation.
Okay. Nice. So you are having like degree in mechanical, chemical?
No, chemical only.
Chemical only. Okay, nice.
Thank you.
So thank you everyone for giving your introduction, and it's really great that we have like a mixed audience. Some of you from like ONGC and some other companies, and some of you from the academia. So it's good to have all of you here. So I hope you will
sir.
join next. Yeah, please.
Hello, sir. There is some problem regarding installation, sir. There is ask for the username and password. I installed the software, but at one step they ask about the username and password. So there is a problem, sir. So
Yeah,
what's
actually,
about username and password?
I think one of you have mentioned this in the chat box. Yeah, if you go through the Q&A,
Just
Notion,
use your
please.
system as a username. I know. I'm adding it again.
Yeah, please add it again. Yeah.
Yeah, I have done.
Sir,
Yeah.
sir, where?
In username only. Don't need. You can leave password empty. It works
Okay.
for me. Yeah.
Okay. Username, sir. It's laptop username, sir.
Huh? No.
Username.
The prompt which comes over there, na, you just put your system in it and just click next. It will be done.
Okay.
System.
Okay, Partner.
Yeah.
So please
Check
try
your chat
to.
box.
Yeah, you can check the chat box, and also you can just type the system as Nutan mentioned. And if you still face issue, then you can also take a screenshot of that, and you can email to the NPTEL team. Maybe they will look into it.
Okay. Thank you.
Okay. So anybody else? Okay. So thank you everyone for joining this session, and I hope you enjoyed it. And let me know if you like if you know any modification in the way we are organizing this session. Okay. So I will try my best.
Yeah, Amit, could you just
Nutan,
facilitate a group creation on WhatsApp if that's what is allowed to you, or if that's what is permitted?
Actually, it's not allowed. I can not say maybe, but you all can do this on yourself. Actually, I cannot make a statement in the chat box and all things. So, but on your individual level, you can do this. Yeah, no issue. Yeah.
Sir, Amit ji, actually I copied a link just now, right now, which is a WhatsApp group. Anyone can scan it and they can join immediately into the group. Actually,
It's no issue if you all.
I kept it a question and answer here only. That anyone wants, they can copy it and they can join in the WhatsApp group with that link.
Yeah, no issue. So if you want on your level, you can do that. Yeah, but I cannot say from my
Okay,
side
I got
actually.
it.
Yeah.
That's understood.
Yes,
Well understood.
WhatsApp group is helpful. Hello.
Yeah.
It's really helpful. Yeah.
Yeah.
And
In
also there is.
Arjunan. Yes.
I can see people joining. That's great.
Yeah.
That's great. Okay.
Also, there is NPTEL. There is the NPTEL form for this course. I think you can also post your questions there. So there also the NPTEL team is there. So they will also resolve your doubts. So no issue in that. You can also use the WhatsApp group. You can use the course form that is available to you, and we can also discuss your doubts in our further classes. So no issue. So I hope you all also will also join in next class. So yeah, please.
Amitji, could you share your mail ID if you have any doubts in research and all? Na? We can discuss further on this.
Yeah. I will share my mail ID. No issue in that. I will share my mail ID. Let me type it.
Okay, sir. Thank you.
Sir, can you please dictate the mail ID, because my question and answer box is not opening due to some problem.
Okay. So it is AKS Amit Kumar Sharma, like short form AKS.IITD@outlook.com.
iittd@outlook.com.
Yeah.
Sir,
I also
repeat again, sir. Please repeat again,
aks.iitd@outlook.com.
Thank you, sir.
Yeah, welcome.
Sir, hello, sir.
Yeah,
Sir,
please.
sir, I'm not able to see the chat box. Can you just check it out so that I can join WhatsApp?
I'm not sure. Why are you not able to see the chat box actually? Yeah.
I am also
Sir,
not able to
it's
see
showing
the
it's
chat.
Yes, sir.
disabled.
Yeah, visual, sir. aks.iitd@outlook.com.
Yeah, aks.iitd@outlook.com.
Yes, sir. Yeah, sure.
Okay. So thank you everyone for joining this session. So actually I enjoyed it very much. Yeah. Thank you. And maybe the next time also
Thank you, sir.
you all will join. Yeah, yeah.
Thank you, sir.
Yeah, so please join next time also.
Thank you, sir.
So we will again have a wonderful session and a wonderful discussion.
Yes, sir.
Okay, so I am ending this meeting for today. Thank you.